How can I power my Raspberry Pi? Well, that's a question we get asked a lot lately, especially since we develop our own Raspberry Pi image for the MoBro PC monitoring software, which you should totally check out, by the way. Well, later after this video. Anyways, so we decided to find and address this powering question in this video, and we're going to take a look at how you can power the Pi inside a case like this one, or outside like this one on the table or whatever. Well, we're also going to take a look at shutting down the Pi automatically when the PC shuts down, and we're going to address some Ooyy symbols that you guys see from time to time. So let's go! Now before we start, let's get a few basics out of the way. First, this video is only going to focus on how we're going to power the Pi. We're not targeting how to flash any of the SD cards with the images or how to install their display drivers. There's a video where we do all of that and it's linked down below and also up here somewhere. Secondly, we've already set up the Wi-Fi configuration and also put together these dashboards right here. But the information about powering the Raspberry Pi is universal and of course also applies if you're using the official Raspberry Pi OS or basically any other available image. Now let's take a look at the different Raspberry Pi models that we have and their power requirements, as they naturally differ quite a bit. While the Pi Zero has a recommended current capacity of only about 1.2 ampere, the recommendation for the Pi 3 and 4 are 2.5 to 3 ampere respectively. The most recent addition to the Raspberry Pi family, namely the Pi Zero 2W, has also increased its recommendation to 2 ampere. By the way, we recently did a video on the Raspberry Pi 2W, so you might want to check that out as well after this video, right? Remember that one. Now for all the other remaining older models, please just check the official Raspberry Pi documentation online. We don't test our images on those anymore, so we don't cover them any further in this video. But generally speaking, you will need less power than those ratings if no display or USB devices are connected to the Pi. On the flip side, if a display is connected via the pins or doesn't have a separate power supply, you might even want to give it a little bit more juice than the recommendations say. Alright, so let's take a look at the different ways how we can power a Raspberry Pi. We split them into two categories: inside the PC case like this one, since that's probably the biggest use case among you guys, and outside for desk usage like this one. Let's start inside with this cable. This is a motherboard to USB Type-C or micro USB cable. A motherboard USB header can deliver anywhere between 0.1 and 1.5 ampere, depending on the USB generation and the type of the port, so you will have to check your motherboard or the port's documentation. As you might notice, these values are quite below the recommended amperage of the Model 3 and the Model 4, but as mentioned, they generally use less than those recommendations, so you might still be fine. Typically bareboard activity current consumption, so basically Pi lying around idling doing nothing, is around 0.5 ampere, and the average when under stress is somewhere around 0.8 for the Pi 3 and 1.2 ampere for the Pi 4. But please keep in mind, these values are without any displays attached. So if you want to power a display over the Pi as well, you might run into power issues, and the Pi itself just freezes, shuts down, or just doesn't do anything at all. Now that's where the Pi Zeros come into play. They just use about 0.1 and 0.35 ampere respectively. So if you decide to go down this route and use this cable, we definitely recommend you to go with the Pi Zero 2W, because it's much superior than the original Pi Zero and it pretty much costs the same. The second option that we have for usage inside the PC case is these Molex to USB adapters. These cables support up to 2.5 ampere, again depending on the cable and as well the power supply of course. This should be enough to power any Raspberry Pi model, even the new power-hungry Raspberry Pi 4. As you can see in this setup, we're using a Pi 3, we're using two Molex to USB adapters, and it works perfectly. Alright, so now to a funny story regarding these Molex to USB cables. We were testing out our setup and we didn't have this awesome PC setup yet, and we were just hooking up one of these modular power supply cables with any power supply that we had lying around. And it turns out that even if they physically fit the 6-pin and the Molex connectors, it doesn't really say that the voltage that you get is the same. So we actually just hooked it up and didn't try or test anything, we just tried it out and we grilled this Pi. It's now completely worthless, and that's because, we measured with the multimeter, we had 12 volt where we should have had 5 volts and we just completely grilled it. So use the cables that came with your power supply, or at least test it out, and don't grill your Pis. Alright, back to topic. As last method, we could even use just one of these normal USB to micro USB or USB Type-C cables and plug it in the back of your motherboard and route the other cable back inside to the case. these ports might even be more capable and deliver more power than the internal motherboard USB headers. So once again, check the documentation. Now let's take a look at all of the options that we have for powering a Raspberry Pi outside the PC case. This is where you can get really creative, as you can basically use anything that's capable of providing enough power over USB. We can of course just utilize any USB port from our PC outside. Another simple solution would be the good old phone charger, which you probably have a few lying around anyway. Just keep in mind to check the fine print on them to see how much amps they are capable of providing. Probably all of them will be good enough for Pi 0, but especially the older ones might not be able to handle a Pi 3 or a Pi 4. Even more so if there's a bigger screen attached. Then there are also a lot of power supplies like these ones. All of those are basically just the same as your phone charger, just with the USB cable directly attached to them. This one here, as identified by the Raspberry Pi logo on top of them, is the official one provided by the Raspberry Pi Foundation. Alright, so moving on to the next one, the battery pack. You can of course just use a battery pack to power your Raspberry Pi. If you haven't seen it, we did just that. We built our own Pip-Boy that's powered by the Raspberry Pi and has a display in front. You can check out the video if you're interested, we'll link it down below. Now naturally, if you can use a battery, you can also use a power bank. After all, it's basically just the same thing, just bigger and inside an enclosure. Just keep in mind to check for the rated amps that it can provide. And lastly, we do have another creative and rather unconventional method, a solar panel. So if you can maintain a constant sunshine to the panel, we should be able to provide our Raspberry with 100% renewable energy. As the Pi 0 requires the least amount of power, we recommend using this one. As an added benefit, our Raspberry Pi will automatically shut down in the evening at sunset without further ado. But jokes aside, this one is a nice fun project, but of course not really usable in practice, unless, well, you would use and combine it with a power bank. But maybe a project for another day. Now let's move away from using Raspberry Pi's USB port and explore some other options. A more technical and thereby also more dangerous way to power your Pi is directly via the GPIO pins. To power via GPIO, you only need to connect two pins. You need to connect a 5V power source to one of the 5V power pins, like the pin 2, and you need to connect the ground of that source to one of the ground pins, like pin 6 for example. It should be noted that unlike the micro USB port, there is no regulation or fuse protection on the GPIO to protect from any overvoltage or current spikes. If an incorrect voltage is applied or a current spike occurs, you can permanently damage your Raspberry Pi. At best, you'll burn out some of the GPIO pins, at worst, you can fry your Pi. So be careful. We don't recommend this method if you don't know what you're doing. Then there's also the option to power your Raspberry Pi directly over the Ethernet cable using the so-called Power over Ethernet HAT, or PoE HAT for short. If you're connecting the Pi by Ethernet anyways, this might definitely come in handy for you. Now we don't have one here, but this is what it would look like. So basically the power is provided over the Ethernet cable to the PoE HAT, which in turn will power Raspberry Pi directly through the GPIO pins, just like described previously. But this time the PoE HAT will take care of the voltage and the current spikes, as it has all the necessary circuitry on it. So it is very much safe to use. Just keep in mind that you will also need a PoE switch on the other side of that Ethernet cable that is actually capable of providing that power. Your regular cheap €20 switch will not work for that. Now let's quickly also talk about another topic that comes up a lot. How do I turn off my Raspberry Pi? Well, this is a highly dependent topic on your use case and where you put your Raspberry Pi. So for this use case again, mainly focus on our Raspberry Pi with a MoBro image flashed on it. If your Raspberry Pi is located outside the PC case, the easiest solution would be to just unplug it. Or alternatively, you can use one of these USB cables with a power switch. Now normally, that's not really ideal, as just cutting the power or pulling the plug might lead to data corruption or data loss. It's basically the same that you just don't pull the plug on your PC to turn it off, right? But good news, we've worked around that issue for our MoBro image. So just cutting the power is no longer an issue. If you're interested in the technical side of this, just search for overlay file system online and you will find everything about it. But that's not something that we want to cover in this video. If you're interested in the technical side, just let us know down below and we'll tell you all about it. If your Pi is connected to an internal USB header on the motherboard, you'll have to make sure that the header stops providing power when the PC is turned off. So in other words, you will kind of need to automatically unplug the Raspberry Pi when the PC shuts down and plug it back in when the PC boots up again. The same principle of course also applies for using a Molex cable instead of the USB header. Depending on your specific setup, so CPU platform or the motherboard, this will already work for you out of the box. But for others it might not, and your Raspberry Pi will stay powered on even if the PC is already shut down. This can mostly be solved by simply changing some settings in Windows, and I can show you. Open the system settings and go to Power and Sleep. Then open the additional power settings. On the left side, select Choose what the power button should do. Note that you need to have administrator privileges in order to do so. Now disable Fast Startup, that is enabled by default, and save the changes. For other setups, you might also need to adjust the power delivery settings in your BIOS, but that really differs between motherboard manufacturers and motherboards in general. Alright, so we've now covered how to power and shut down your Raspberry Pis. But additionally, for some displays, you might also need to power them separately. The smaller ones can mostly utilize the headers on the Raspberry Pi for power, while the bigger ones might need to require more power and an additional USB cable that needs to be either provided directly to the display or to a display board. As an example, in the PC case that we have right here, we're using two separate cables, one for the Pi and another one for the separate display board that is stacked right on top of it. Both are connected via the modest micro USB cables and automatically power down when the PC shuts down. For the display that needs extra power, the same guidelines as we mentioned before for powering Raspberry Pi also apply. So now to the last topic, the overlay symbols. Some of you have already spotted these and asked us, what's up with those lightning and thermometer icons? Well, let me explain. Well, the lightning display overlay basically equals to under voltage, too little power. On all the models of the Raspberry Pi, except on the zero range, there's a low voltage detection circuitry that will detect if the supply voltage drops below 4.63 volts with a rarity of 5%. This will result in that lightning warning icon being displayed on all attached screens. Voltages can drop for a variety of reasons. For example, the power supply itself is inadequate, the power supply cables are made of too thin wires, or you have plugged in high demand USB devices or a screen. If you keep seeing this icon, you should improve your power supply or the cable. Low power can cause problems with the corruption of the SD cards or erratic behavior of the Pi itself, such as unexplained crashes. The purpose of the second overlay icon, the thermometer, is to indicate the critical temperatures and overheating. When the core temperature is between 80 and 85 degrees Celsius, a half red fill thermometer will be shown. In addition, the CPU cores of the Pi will progressively throttle back, so in other words, you're losing significant amounts of processing power as your CPU slows down in an attempt to keep the temperatures in check. Once the temperature reaches over 85 degrees Celsius, this icon shows a full-filled thermometer. At that stage, both the CPU and GPU will be throttled back. If you keep seeing these for prolonged times, we highly suggest to look at your cooling. We generally recommend the use of a heatsink, especially on a Raspberry Pi 3 and even more so on a Raspberry Pi 4. Also make sure that there's always at least some kind of airflow for the Raspberry Pi and it's not completely sealed off. Alright guys, these are all the tips and tricks for you today on how to power your Pi, make sure that it shuts down with your PC, and also the overlay icons explained that you don't kill your Pis. If you found this video helpful and you liked it, make sure to toss us a like, consider subscribing if you want to see more content like this one, and also if you want to help us out even more, there's a Patreon link down below where you get behind the scenes content and also preview versions for the new and upcoming MoBro. It will be really awesome and improved, so stay tuned and see you guys next time.